My name is Chris Cholmeley. I'm Application Engineer Manager at Victrex. And I'm going to talk to you today about our experience being in a cloud-based PDM system to solve the problem of effective remote working for design engineers in our post-COVID world. Victrex. Who's that? Well, the name Victrex may not be well known outside the plastics industry, but our main product, polyether ketone, or PEEK, has been widely used across industries where high performance is required from plastics since its invention by ICI over 40 years ago. The PEEK business of ICI became Victrex in 1993, and today we remain a leading supplier of PEEK and related polyketone polymers. And this slide gives some facts and figures about the company. As well as a supplier of the PEEK material for injection molding or stock shape manufacture, Victrex has expanded the value chain over time to offer a variety of PEEK compounds and specialist product forms such as films, fibres and composite tapes. Beyond forms, to the yellow area, we also work to develop parts in selected application areas, and it is within this parts business that my team operates and the subject of today's presentation. Well, what is PEEK then? PEEK is a high-performance polymer sitting close to the top of the polymer pyramid that is often used to classify plastics, and we see that at the top left-hand corner of the screen. The shape of the pyramid gives us clues to the relative performance of high-performance polymers versus commodity polymers at the bottom or engineering plastics somewhere in the middle. This includes properties such as mechanical strength, tribological performance, and resistance to harsh environments. The pyramid also highlights the relative volumes of different polymer groups used across industries, with commodity polymers at the bottom used in significantly larger quantity than specialist high-performance materials. Sustainability is an increasingly important consideration for all equipment and material manufacturers. The PEEK is a world away from the cheap commodity polymers and those commonly referred to as single-use plastics. Due to its high value, PEEK will normally only be specified but absolutely required based on the mix of material properties detailed on this slide. And these are just some of the key factors that we end up discussing with customers. It's also a thermoplastic, meaning it can be remelted and reformed to allow recycling, whereas many competitive high-performance polymers are thermosets and cannot easily be reprocessed. Our engineering team are mainly focused on gear applications, but it is just one of our strategic growth platforms in the automotive sector, where we aim to increase the average mass of Victrex PEEK in passenger cars from around 10 grams today to 150 grams in the next few years. Much of that increase is expected to come from widespread use of PEEK as insulation layer on e-motor wire and as slot liners for high voltage electric vehicles, and that's the image at the bottom left-hand corner there. Victrex has similar product development teams working to support the incubation of thermoplastic composites applications for aerospace, such as aluminium replacing brackets that we see in the middle of the screen there. And we have numerous implantable medical devices using a variety of manufacturing technologies, such as injection molded knee joints and spine cages, and composite trauma plates, which is this one here. Victrex is also involved in the development of both materials and processing technology for additive manufacturing, opening up the possibilities for high-strength PEEK prototyping and tailored one-off component manufacture that may be particularly suited to further medical applications. Whilst Victrex does not have a direct role in the part design in some other important industries, Victrex PEEK is also used extensively in the electronics industry, such as small space enclosure speakers, so using your smartphones with mobile devices. It's also used widely in things like the energy sector for bearing and sealing applications. The raw polymer material is developed and manufactured in our main UK site near Blackpool, Lancashire. And PEEK fibres, as those used in filament deposition 3D printing, are developed at our site in Gloucestershire. Victrex also has a worldwide footprint, including additional technical centres regionally in the US, China and Japan, as we see on this slide. Victrex has administrative offices in many of our customer target or customer market territories, and large numbers of remote working employees around the world across functional areas. And it's Victrex's progressive attitude towards hiring and hybrid working that led us to recently decentralise our gears engineering team to be able to support local markets with the best talent available regionally. So if you come into my gears engineering team in the focus of this presentation, between 2021 and 2022, Victrex's gear design engineering team evolved into a global structure covering US, UK and China in readiness to support local market opportunities across transport and other industrial applications. The IT infrastructure to provide key engineering tools evolved out of a single US-based IT network, subsequently adapted for remote working during COVID times, with all users using remote desktop access to a single server located on the site. This is no longer a sustainable solution as the team matured, due to frequent stability problems outside the US, as well as potential end-user license agreement infringements. To make use of local CAD resources in each region, the engineering team required a system to manage and control data centrally. So a formal project was initiated last year to investigate solutions to provide a common product data management or PDM system. Selecting the right PDM system will also allow us to address ongoing concerns around our revision control and release process. I myself come from a long background using Teamcenter in my last company, so the idea of using a Windows file-based system for controlling revisions and release of data was fraught with concerns for me. So onto our project, we quickly came to put together a wish list of high-impact objectives for the PDM system, including centralised CAD data storage for 5 or more international users initially, but really a platform that will be scalable for potential expansion to wider Victrex teams in the future. We need a reliable CAD infrastructure with real-time collaboration capability across the team and across the globe. I was very keen for an integrated file management interface accessible directly within CAD, both for ease of use and to maximise the user engagement with the underlying system. We need a workflow-based data review and release process. We need revision control. We need a file access control based on user groups. All those things that mature companies tend to have. BOM management of assemblies and components with consumed subcomponent structures. This was quite an interesting one for us because none of our peak gears are overmolded directly onto a metallic component. So in a CAD world, the parent part geometry is dependent on that subcomponent. And maintaining a parametric structure in a native SolidWorks environment was recognised as a weak point of our existing process. We also wanted to be able to automatically create standard engineering output files upon release of data. This is a requirement for us because certainly in the immediate term, we'll be working with customers and or manufacturing partners that are not integrated into the PDM environment. So that data will have to be exported in neutral formats once it's been approved. And last on the list there, the wish list was at least the ability to be able to store non-CAD related documents. In our world, gear data files, quality forms, things like that, alongside the data sets that relate to the product design. So, we obviously had looked at the marketplace, we looked at alternative systems, and these are 4 of the main ones we looked at. The first one on that list is called Onshape. Onshape is a fully cloud-based CAD system with integrated file management, and something that I'd used myself for a few years for occasional CAD work at Victrex. Lack of infrastructure and special hardware costs and simple system configuration were attractive for this option, but questions were raised by my team over the capability of Onshape to replicate complex mathematical gear profile modelling being developed in SolidWorks. There was also an enhanced business continuity risk moving to an all-new CAD system, and with individual licenses being required for all the users from the start, it meant the outline costings were not compelling compared with the alternatives, particularly building on existing Victrex SolidWorks licensing that itself can serve a wider pool of users
i.e. we have floating licenses and we have more users than we have licenses because they're not using it all the time. The second one on the list here is Windchill. Windchill, again, a well-known PLM system, and it's something that's already used at one of our Victrex sites in our medical division. It's all cloud-based and would interface with local SolidWorks installations. But the PDM software is not native to SolidWorks or vice versa. The CAD integration functionality had already been proven, but certainly on the face of it, that user friendliness of seeing the file management directly in the CAD environment still had some work to be done to really make that seem user friendly and an easy sell for my team. The estimated costs were also not any cheaper than Dassault alternatives, and Victrex IT department noted that the license administration for our existing Windchill system is not straightforward, so it was met with some internal resistance. Having ruled out both of these options, we started to work with Technia and their sales and technical teams to scope out the Dassault alternatives. The first one on the list we see here, SolidWorks PDM. Again, it's a product we've already got within the Victrex group at one of our sites in the US. It offers good interoperation with locally installed SolidWorks and would be a natural choice for my team as they're working solely in SolidWorks CAD environment. However, the on-premise PDM server hardware would be required in each Victrex location, and bear in mind we're trying to connect multiple international sites here, so we then need to synchronize data between servers, and the infrastructure cost and complexity therefore becomes quite high. After experiencing the software as used by a US team, we found it was also limited in functionality beyond the very basic brief of providing a common folder-based filing system to all of the system users. We also anticipated perhaps a limited life expectancy of this on-premise solution as the world moves towards cloud-based alternatives. So, having ruled that out, we came to the last one on the list here, and Victrex's chosen solution of the 3D Experience platform. 3D Experience, and apologies because I may abbreviate it to 3DX, just instinctively as I talk through, it provides a choice between on-premise, server-based, or a cloud-based data management system with a wide range of add-on apps available from the Dassault portfolio. With the public cloud-based option that we went for, it required a low initial investment as all the costs were annual licensing per user, and it works in harmony with locally installed SolidWorks on user PCs. 3D Experience has an international coverage via Amazon Web Services with synchronized regional data servers in the US, France, and Asia available to serve our users. The move to locally installed SolidWorks for my team, we had to increase the number of floating licenses in our UK pool and also in China. And at the same time, we chose to migrate all of our UK SolidWorks licenses to Technia as a one-stop shop for our UK Dassault CAE tool support. And with support from Dassault themselves, we were also able to align license periods for ease of future administration between 3DX and SolidWorks that we already had. This diagram here gives a bit of illustration of the architecture of the system that we've put in place. We have a total of 5 engineers with full access to the system, based in the US, UK, and China, and they're using native SolidWorks from the license pools in their regional Victrex technical sites. Currently in progress is the top item on there, which is the onboarding of our US manufacturing collaborators who will initially have collaboration access only to the system to make use of the review tools on the platform, and will continue to work in native SolidWorks as they take that into the manufacturing environment. Well, this slide's got just a very simple overview of the key workflow that we use, taking design through a review process and into release using the 3DX platform. The components are modelled and drafted in SolidWorks and saved directly to the platform by the designer wherever they are located. We use the freeze maturity status as a soft release marker, and whenever the design is circulated for peer review, and then we resume design changes with a minor revision so we can keep an auditable design history, and that's something that we were very far away from being able to do in a native environment. The design review process is engineer-led, using a predefined route template that can be customized to control the relevant circulation to design team members and additional collaborators with access to the platform. 3D markup is used extensively to capture feedback from individual stakeholders that will then get incorporated by the designer into the design before resuming the review route, the review cycle. Once the design has been approved by all stakeholders, the relevant files are released by me as the engineering manager, and this triggers automatic creation of PDF drawings and step 3D models using the derived format converter. So we get to the right-hand end here. As I said earlier, it's important to note that currently we're exchanging data with both customers and our manufacturing partners outside of the platform. So PDF drawings and step models remain the principal outputs from the engineering process. In the future, we hope to be able to widen the scope of 3DX to bring SolidWorks-based injection molding tool design onto the platform, at least for our internal manufacturing capability based in the US. So, how did the project go overall? Well, the first thing to note is extended project time scale. It took much longer than we initially anticipated to get the system ready to go live. And in total, it was about 12 months from the start of the project, the first scoping activity and quotation, to getting to go live with real data. Even 5 months from placing a purchase order in February of this year to July, where we were using the system in earnest. This is partly due to the complex logistics of working with 3 engineers based across the globe, none of which had prior experience with the system, and they also had a day job to do as well. So they had responsibilities throughout the project timeline. They weren't able to dedicate their time to it. Second point here is about system administration and configuration burden. It is a cloud-based system, but it also interacts with locally installed native apps that link to things like SolidWorks. So because we were running this project as a design team without a sort of management from our company IT team, and that lack of IT team ownership of the system meant that we were sometimes slowed down by needing to get network administrator on board to help with software installations or configurations on user PCs, particularly in the early days. We also found some problems with VPN systems and network file work rules. They seem to be not very well documented ahead of the software rollout process, but largely, or likely to be largely due to Victrex's own corporate IT security configuration and network rules. So a lot of these problems we could only find by trial by fire as we went through the project. But I was working with Technica's technical help desk. They were able to help us resolve or come up with suitable workarounds for some of the issues we found. Also, our rollout being spread out over 6 months, we also had something of a moving target of regular Dassault system updates. It's included 2 major and mandatory native apps updates during our rollout period, as well as numerous minor hotfix changes that did result in some changes to front-end and core functionality whilst we were still learning the system. The biggest challenge, point number 3 of this, what are the 3DX best practices? And I think anyone that's brought a new software system in could probably empathise with this experience. We had to work out what elements were essential for our minimum viable product at go live, based on that initial list of requirements. And we then had to work out what are the tools and the best practices to achieve those using the system. What we didn't know was how some of the software functions were intended to be used or how they're interlinked in the background. It was clear that some of the elements of the software were so interlinked that we couldn't ignore them at go live. We had to then implement maybe changes to our process, our working practices, things like revision rules, revision systems, and the way we do the attributes we use for part naming. All those things we had to work out the best way of doing it. This is where a connection with the Technia product specialist was critical to our success, although we are now aware of external consultancies that specialise in this kind of activity and might have made the process more streamlined with engagement earlier in the project. So I'd recommend this route to anyone considering the adoption of a new PDM or PLM system. Having said that, we as Victrex were quite fortunate because we had a lot of flexibility to change our standard engineering processes to suit the software, due to being both a small team and without rigid operating procedures locked into a quality management system. That's something that really comes about because of our role in the value chain is very much in front-end proof of concept prototyping, as opposed to production path tying in with standards like IATF 16949, which is used extensively in the automotive world. The last point in here, I'll note, again, a bit of advice to anyone else bring a system in, is about team engagement. Without a dedicated project team to develop the system offline of Victrex, it took some time to get all members of my team actively engaged in the project and to see it as something beyond just an additional overhead to the day job. What made a significant difference in my project was the availability of a fifth member of the team, a recent graduate on secondment, who was able to dedicate more time to testing and issue resolution, as well as documentation. And with that, it was much easier to get the rest of the team to engage on the final details of the system when they could see the value from the benefits the system brings. My last slide here is a very high view of a kind of roadmap we have for CAE amongst my team and other parts businesses in Victrex. And the green coloration here shows an illustration of our progress against that roadmap as we see it now. So we've completed the initial rollout of 3D Experience within our current financial year, which is about to end. So when I say FY23 on there, that's our financial year. In the next 12 months, the next section on there, we're really looking to evaluate additional 3D Experience platform functionality, determine which tools could improve our current engineering processes. And that includes things like change actions, issue management, FMEA, project management. We could probably add some other things to that list as well once we've kind of got the bandwidth to start investigating things further. Beyond that, also looking at the next 12 months, is really trying to establish part structural analysis business case, so FEA. In parallel to the 3D Experience platform rollout, we've been working with Technia's Engineering Services Division, and Jake, who's sitting over there, thanks for coming on, Jake, on a number of FEA projects as we seek to understand the breadth of structural analysis tasks that we want to consider bringing in-house in the future to support gears and other parts businesses within Victrex. The ultimate aim is to identify the 3D Experience-based FEA tools and roles that would be required for the typical tasks in our target application areas to build a business case for in-house investment. And whilst we're doing that, we're building a regular outsourcing relationship with Technia for future on-platform FEA design optimization of new or difficult products and a knowledge transfer process for repeat analysis in-house. As we get to the top of this, so we're looking more than 12 months away, which is really where we're then looking to see how we can extend the use of 3D Experience within Victrex Group. So that could be to other Victrex parts engineering groups, and also the potential to expand access to the data via the platform to selected customers and external manufacturing partners. That's likely to tie in with sort of overall reorganisation and development of our in-house personnel. And we're likely to see greater standardisation of engineering process and tools and shared engineering resources across Victrex enterprise in the future. So having the 3D Experience platform as a backbone of a scalable and accessible CAE system will be crucial to our success, as will a close relationship with partners such as Technia for outsourcing and knowledge transfer. And with that, I conclude this presentation. I'm not sure how we're doing on the time. I haven't looked at my watch. And I look forward to discussing any aspect of our 3D Experience journey with you later during the show. So please come along to Technia stand on A25 if you have any questions, or feel free to send me a message on LinkedIn. Thank you for your attention.
Thank you, Chris. That was excellent.